Welcome to this online revision session for AQA FP4, in which we'll be looking at the June 2011 question 8 on vector geometry. As you can see, we'll be given the equation of a plane. Remembering this vector here, 3, negative 2, 6, is the normal to the plane. And here we've got the standard form of a vector equation of a line as a plus lambda d, where a, the vector 1, 2, negative 7, is a point on the line, and 2, 1, 2 is the direction vector of the line. And if you read through the rest of this question, you can see we've been asked to do various things related to this line and a plane. So, let's get started on the first part of this question, where you can see we're being asked to determine the value of the angle between the line and the plane. Very much a standard textbook sort of a question for you to do. Since we know the direction of the line, given by the vector 2, 1, 2, and we know the normal is 3, negative 2, 6. It's this vector here. Then by using the scalar product, we can determine the angle phi up here, and since these two angles add up to 90 degrees, we know that the cosine of phi will be equal to the sine of theta. So, using our scalar products then, we know that n dotted with d will equal the length of n times the length of d times the cosine of phi. So if we rearrange that, we know that the cosine of phi will be equal to n dot d divided by n times d, where n and d are the length of the vectors. Okay, so we need those various things. So we need to work out the length of n. So that is going to be the square root of 3 squared, negative 2 squared, and 6 squared, which is going to give us 9, and 4 is 13, and 36 makes 49. So that's the square root of 49, which is 7. And similarly, the length of d will be equal to the square root of 2 squared plus 1 squared plus 2 squared, which of course is 9, and the root of 9 is 3. Similarly, we now need to work out n dotted with d. So that's the scalar product of 3, negative 2, 6 with 2, 1, 2. Remembering to work out the scalar product, it's 3 times 2, which is 6, plus 1 times negative 2, which is negative 2, plus 2 times 6, which is 12, which gives us 16. And so, going back to the cosine of phi, it's n dot d over nd, which is going to give us 16 over 7 times 3, which of course is 21. So remembering that that is the same as the sine of theta, the relationship between these two angles, we know the sine of theta is 16 over 21. And so, on our calculators, remembering of course that your calculator needs to be set in degrees for this part of the answer, this must be 49.6 Remember, and it's only to one decimal place that we require the answer there. Okay, well, there's 4 marks for doing this. You'll get a method mark for clearly understanding and showing how to find the sine or the cosine of theta there. For getting the 16 from the n dot d, you'll get a mark. And then for obtaining the 2 correct values, the 7 and the 3, to give you the 21, getting the 21 here, you'll get a mark. And then finally an accuracy mark for getting the correct angle. Okay, into part B. Now in this part we're being expected to find the coordinate of P, and you remember P is going to be the intersection of the line with the plane. So we need to find the intersection, so that means that the equation of the line needs to fit into the equation of the plane in order to find the point of intersection. Remember, the equation of the line, you're probably better to write it as 1 plus 2 lambda, 2 plus lambda, and negative 7 plus 2 lambda. So it's a single vector that can be put into the equation of the plane when you do the dot product. So to do that then, we have 1 plus 2 lambda, 2 plus lambda, and negative 7 plus 2 lambda, and we've got to dot that with 3, negative 2, 6, and we know that that must give you an answer of 37. So working out the scalar product on the left hand side, we got 3 times the 1 plus lambda, so that will give you, the 1 plus 2 lambda, which gives you 3 plus 6 lambda. And then we got negative 2 times the 2 plus lambda, which will give you negative 4 minus 2 lambda. And then we got 6 times the negative 7 plus 2 lambda, so that's negative 42 plus 12 lambda. And again, that's still equal to 37. Simplifying this then, we got 6 lambda, take away the 2 lambda, which is 4 lambda, plus another 12 lambda, which is going to give you 16 lambda. And then what have we got? We got the negative 42, we got a negative 4, so that's negative 46 plus 3 gives us negative 43, so if we take that across to the other side, that will give us 80. And so lambda must equal 5 at the point where these two intersect. So to find what the point is, if we now substitute that into the equation of the line, that will give us the value or the coordinate of P. So putting 5 in, we get 1 plus 2 times 5, which is 11. 2 plus 5 times 1, which is 7. And negative 7 plus 5 times 2, which will give us 3. Okay, well, how do they allocate the 4 marks for this part? Well, again, the method mark here for knowing or identifying that you have to substitute the line into the plane. Managing to get the scalar product calculated correctly from here. This statement here will give you a mark. And then for obtaining your value of lambda and getting the correct value there, you'll get 1 mark. And then for the statement as to what the value of P is going to be, you'll get 1 mark there as well. Okay, finally into part C of this question. You're told that there is a line L1 lying in the plane such that the angle between L and L1 is theta. In other words, if you look directly down vertically from above the plane, L1 is directly below L. And in part 1, you're asked to find a vector which is parallel to the plane and perpendicular to L. So you can see here I've drawn this purple vector, which is the direction of the line. The red vector is the normal. So this is N. This is D. And so the vector we require is this green vector, which is perpendicular to both N and D. Because if it's perpendicular to N, it must lie in the plane, and to be perpendicular to D as well. So this angle round through here is 90 degrees between them. And so this is the vector we require. So to find that vector, so it's perpendicular to these other two, we can do the cross product or vector product. So part 1, to find the vector we require, we need to work out N crossed with D. And so we're going to do the cross product, and I think we'll set that up using I, J's and K's in this particular case. So it's I, J, K, and the normal is 3, negative 2, 6, and the direction vector is 2, 1, 2. Okay, so we now work that out. Firstly, to get the i's, it's the determinant of negative 2, 1, 6 and 2. So that's negative 4 minus another 6, so that's negative 10. To get the j's, remembering it's plus, minus, plus from the grid, it's going to be the determinant of the 3, the 2, the 6 and the 2. So it's 3 times 2 is 6, take away 6 times 2, that's 12. So 6 take away 6 is negative 6, but you've got the negative in the front, so that's positive 6. And then for the k's, it's 3 times 1 minus 2 times negative 2, so that's going to be plus 4, which gives you an answer of 7. So this is the vector in the plane, which is going to be perpendicular to D. Now in part 2, it then says we want the vector equation of this line L. Well, this vector equation of the line L, we need to know the direction, call it D1, of that line. So we need to find that direction vector. Well, that direction vector, since it's directly below D, must be perpendicular to the vector that we just found. And since it's in the plane, it must also be perpendicular to the normal. So if we now do the cross product of the normal with the new vector that we just found that's perpendicular to the line in the plane, that will find us the direction of D1. So to find D1, we have got to do the normal dotted with this direction vector. Okay, does it really matter which way round we do it? Not really. So if I do N crossed with the negative 10, 6, 7, that's going to work. So again, if we should write that out as IJK, the normal is 3, negative 2, 6, and this is negative 10, 6, 7. And so what are we going to get? We're going to get 3 times 6 is 18. No, sorry, pardon. Starting with the i's. Negative 2 times the 7 is negative 14. Take away another 36. That's going to give us negative 50. Similarly, to get the j's, remember there's a negative sign on that one, as in the previous example. 3 times 7 is 21. Take away negative 10 times 6. So that's negative 60 taken away, so let's add it, so that's plus 60, which makes 81, but again it's a negative. And likewise for k, it's 3 times 6 is 18, take away 20, so that's negative 2. Well, all of those signs on that vector are negative, so remember in the direction vector can be in either direction, so we can quite happily use 50, 81, 20 to avoid all the negative signs. And so your position vector will be a point on the line. Well, we know the point P is on the line, and P is going to be 11, 7, 3. And then it's plus lambda lots of, well, not lambda, sorry, in this particular case, if you look at the question it says mu, and so it's mu lots of 50, 81, 2. Okay, so where do we get our marks for each of these parts in this question? Well, we'll get a method mark in the first part for realising we need to calculate a cross product. We get 1 mark for an attempt at working out that product successfully, and an accuracy mark for obtaining the correct answer. Part 2, you'll get 1 mark for bringing forward the fact that this vector here, A, is the same as the point P that you found in the first part of the question. And then for using a cross product, to calculate the vector for B, you'll get a mark, and then an accuracy mark for obtaining the correct vector, whether it's the negative version or the positive version, doesn't matter. And then for a full statement of the correct vector equation, you'll get a mark by the accuracy of that at the end. Well, hopefully you found that solution helpful. For more work and support for your further maths revision, please go to the Further Maths Support Programme website.